Dear students, we continue the chapter continuity and differentiability. We already studied continuity and solved some problems also. We solve the problem, check the continuity of the function at a given point, and other problems like the function is continuous everywhere. We solve again some more problems today on continuity. Now, is the function, yeah, defined by f of x is equal to x plus 5, x is less than or equal to 1, and x minus 5 if x is greater than 1. A continuous function. Here is the function f defined by f of x equal to x plus 5 if x is less than or equal to 1 and x minus 5 if x is greater than 1. A continuous function is a question mark. We check the continuity here at x equal to 1 and x is less than 1 and x is greater than 1. Because we check the continuity everywhere in the real life, because the function is defined at every point of the real life. Because x is less than or equal to 1, if the real number is the 1, x is less than or equal to 1, x plus 5, the function is defined. If x is greater than 1, the function is defined at every point of the real life. That the domain of the function is set real number. Set a real number. The function is defined at every point of real number. Domain of the function is R. You should go through the every step of the. Sorry, I defined in the problem. First, you write the function is defined every point or point. Then, domain of the function. Write the domain of the function. And check the continuity when x is less than 1, greater than 1, and x equal to 1. In case 1, here, let A is a point, this belongs to R. A is a point which is belongs a real number, belongs to R. Then case 1, A is less than 1. A is less than 1. The number A is less than 1. We take here. We check the limit of the function. X tends to A, f of x, which is equal to limit of x tends to A. F of x is here less than 1. It becomes x plus 5 therefore which is equal to a plus 1. Then f of a, f of x equal to x plus 5. Therefore f of a is equal to a plus 5. Therefore limit of x tends to a, f of x is equal to f of a. Therefore the function is continuous at x is less than 1. X is less than 1. Then we take case 2. Here we take a is greater than 1. A is greater than 1. Here the function x is a is greater than 1. The function is x minus 5. X is greater than 1. The function becomes x minus 5. Therefore, limit of the function x tends to a, f of x is equal to limit of x plus 5, x minus 5 greater than 1, x minus 5, which is x tends to a, which is equal to a minus 5. F of a also is equal to a minus 5. Therefore, limit of x tends to a, f of x is equal to f of a. Therefore, the function is continuous. The function is continuous and x is greater than 1. Here less than 1. Here greater than 1. Then in case 3, we have to check the continuity at a is equal to 1. Here we have to check the continuity at left hand limit and right hand limit and equal to 1. F of a. LHL, which is equal to limit of x tends to a, f of x, which is equal to LHL a minus x plus 5. Limit of x tends to a minus x plus 5, which is equal to a plus 5. Not a. Here a is equal to 1 minus. Therefore, we take next one. Then it is equal to 1 plus 5, which is equal to 6. Then RHL is equal to limit of x tends to 1 plus f of x, which is equal to limit of x tends to 1 plus means greater than 1. It's x minus 5, which is equal to 1 minus 5, which is equal to minus 4. Here RHL is not equal to LHL and f of a not equal to f of a. F of a is equal to this one. It's 6. Therefore, it's not coincide. Therefore, the function is discontinuous or not continuous at x equal to 1. Therefore, f is not continuous at x equal to 1. Therefore, the point of discontinuity is x equal to 1. Is the function we have defined a continuous function? No, it is not continuous function. The point of discontinuity is x equal to 1. The point of discontinuity is x equal to 1. You once again follow the steps here. I solved some more problem in the previous class also. I solved some problem. Today also I solved this problem because you understand the steps properly and follow the steps while solving the problem. First, the function is defined at every point of not you check. Then find the domain of the function. Here, domain of the function is R because it defines all the terms of the real number. Then you take case 1, k is less than 1. You check the continuity of the function everywhere. First, less than 1 and greater than 1 and a is equal to 1 or x equal to 1. First, a is less than 1, the function is continuous. A is greater than 1. You take the case a is less than 1, you check here less than 1 is the function this one. Greater than 1 it is the function because f of x is a function x plus 5 if x is less than or equal to 1 and x minus 5 if x is greater than 1. Then only you put the case to a is greater than 1, a bit of x tends to be f of x is x minus 5. Then the function is continuous at x equal to 1. Therefore, the function is continuous everywhere, but only this direction at it is discontinuous at the only point x equal to 1. You can draw the graph also, it's not necessary, but you understand the function. You already studied the modulus function also. I take up one more problem here. Mod of x divided by x if x is not equal to 0 and 0 if x is equal to 0. Yeah, mod of x divided by x if x is not equal to 0 and 0 if x equal to 0. This can be written as here also we check the continuity of the function. Check the continuity of the function. Here we rewrite the modulus function as f of x equal to here we take x equal to plus 2 divided by plus 2 is equal to 2 by 2 is equal to 1. If we take x equal to minus 2, it also minus 2, its modulus, it's 2 divided by minus 2, 2 to cancel, but it is minus 1. You take the positive end of the x, you get 1 is the answer. X value, it may be the x value is not written here. It may at any point you take x equal to value in the real numbers, but here it is positive number. The answer is 1. But its negative number is equal to minus 1. Therefore, we rewrite as minus 1 mod of x. The function is minus 1 if x is less than 0. It's a negative number. For all negative numbers, the function is minus 1. It is plus 1 if x is greater than 0. 0, it's already given if x is equal to 0. Yeah? Minus 1, the function is x is less than 0. The function it is minus 1 if x is less than 0. If it is 1 if x is greater than 0. 0 if x is equal to 0. Here, the function is defined every point of the real number. Therefore, domain of the function is R. Domain of the function is defined on all real number or on real number. The domain of the function is equal to R. Then we check the continuity at x is less than 0 and greater than 0 and equal to 0. Case 1, let A is a real number, A is belongs to R. Let A is less than 1. Here case 1, A is less than 1. Then the function is limit of x tends to A, f of x is equal to minus 1. It's not x if it is x equal to minus 1 except it's equal to f of A also. Therefore, the function is continuous and A is less than 0. Less than 0. Then case 2, A is greater than 0 function. You can write here plus 1. It's a constant number. Therefore, it is equal to 1. Therefore, you can write the answer also. Here f of a also 1. Therefore, limit of f of x is equal to f of a is equal to 1x. Here also 1. The function is continuous and a is greater than 0. Here the function is continuous and a is less than 0 and greater than 0 also. Then the function is in case 3, we have to find a is equal to 0. Then the function LHL limit of x tends to 0, f of x which is equal to 0 by 0 is equal to 0. Then RHL 0 by 0 minus 0 minus 1. It is minus 1. Here it's minus 1. Limit of x tends to 0 minus 1 which is equal to minus 1. RHL is equal to limit of x 0 plus f of x which is equal to limit of x tends to 0 plus x is equal to plus 1 is plus 1. Therefore, our LHL is not equal to RHL. Therefore, the function is not continuous, and the point of discontinuity is 1. The point of 0. The point of discontinuity is 0. Not equal to 0. Therefore, the function is discontinuous and x equal to 0. X equal to 0, the function is discontinuous because you can have the graph also here is 0. Every positive number, the function is 1. There is 1, it's minus 1. 1. The function is 0 here. There are also minus 1. It's not here. But here is 0, that's equal to 0. You can draw the graph in one stroke. Therefore, the function mod of x divided by x. If x is not equal to 0, it means if it is greater than 0 or less than 0, the function is mod of x divided by x. If x equal to 0, then the function is 0. Therefore, the function is discontinuous. At 0, the function is continuous everywhere except x equal to 0. You can follow the steps and solve the exercise problems. There are so many problems in your exercise. I think 18 or 20 problems are there on this type. You check the continuity that you can follow the steps. You can familiar about the steps of the solving continuity problem. To solve another problem, fifth one. F of x equal to x cube minus 3 if x is less than or equal to 2 and x square plus 1 if x is greater than 2. I will discuss the problem, but I didn't write the problem here, solve the problem, but I will say the following steps which are here. X cube minus 3 if x is less than or equal to 2 and x square plus 1 if x is greater than 2. Check the continuity of the function. Check the continuity of the function. Here, the domain of the function is here less than or equal to 2, it's x cube minus 3 and greater than 2 is x square plus 1 and it's equal to 2 also x cube minus 3. Therefore, the function is defined for all real numbers. Then, domain of the function also R. Then you check the continuity of the function at x is less than 2 and greater than 2 and x equal to 2. Here x is less than 2, the function is x cube minus 3. F of x is x cube minus 3 and x is less than 2. Then the function is greater than 2, the x square plus 1. We check the continuity here. We check the continuity here. X is less than 2. It may be taken as a is the function here. F of a is less than 2. If a is less than 2, a is equal to a cube minus 3. Then limit of the function of x tends to a, f of x or x cube minus 3 is also a cube minus 3. Then here also check the continuity. F of a is equal to a square plus 1 and the limit of the function x tends to a plus a square plus 1. Here the function is continuous because f of a is equal to limit of the function in the case 1, therefore the function is continuous at x equal x is a is less than real number is less than 2. Here also x is greater than 1. Here also it says a square plus 1. This also x square plus 1 which is equal to a square plus 1. Here also they are equal. Therefore the function is continuous at x equal to x. A is greater than 2. We check the continuity at x equal to 2. LHL limit. Here LHL limit is equal to limit of x tends to 2 minus f of x which is equal to here less than x cube minus 2. Limit of x tends to 2 minus x cube minus 3 which is equal to 2 cube minus 3 which is equal to 8 minus 3 which is equal to 5. Then limit of the function x tends to 2 plus f of x which is equal to limit of x tends to 2 plus x cube x square plus 1 which is equal to 2 square plus 1 which is equal to 4 plus 1 which is equal to 5. Here RHL and equal to LHL. Here it is RHL. Here LHL and RHL are equal and f of 2 also equal. Check the f of 2 is equal to less than or equal to, therefore we put the value here only. Therefore 2 cube minus 3 which is equal to 8 minus 3 is also 5. Therefore it is equal to f of 2 also. Therefore the function is continuous at x equal to 2. Or function is continuous everywhere is less than 2 and greater than 2 and x equal to 2. The function is continuous everywhere. Now we solve some problem like trigonometric functions. We studied algebra of the continuous functions. If a, f and g are the two continuous functions, then f plus g also continuous functions, f minus g also continuous functions, and f into g and f divided by g is not equal to 0 are also continuous functions. We studied in the previous class. Then we studied trigonometric functions. Trigonometric functions like sin x and cos x also continuous functions. Then usually we know the graph of the functions also. Yeah, continuous functions. We discuss the continuity of first one, cosecant function. Second function. And third one, tangent function. Discuss the continuity. We know about the sin x and cos x functions are continuous functions. We check the continuity of cosecant, secant, and tangent or cotangent functions. First, let f of x equal to cos of cosec of x, cosec x. Cosecant condition is cosec x. Here, we already know cosec x is 1 by sin x. 1 by sin x. Where sin x should not be is equal to 0. Where sin x is 0, what? N pi. N pi means 5, 2 pi, 3 pi or 0. The function is sin x functions are 0. Therefore, x is not equal to n pi. N can be taken as 0, 1, 2, 3, etc. Here, domain of the function, therefore we can domain of the function is equal to r minus all real numbers is r minus x belongs to r. Here sin x is equal to 0. Where sin x is 0, no? Therefore it is not here. R minus x is belongs to r. Sin x is equal to 0. Points are not here. Means x is not equal to x is equal to n pi. Then a is belongs to r. The domain of f. I think domain of f means r is minus of this one. Is the domain of the function. Yeah, domain of yeah. Then you can find the limit here. Limit of x tends to a, f of x is equal to limit of x tends to a 1 by sin x, which is equal to 1 by sin a. Then f of a also is equal to 1 by sin a. Therefore, they are equal. Sin a is equal to 1 by sin a is equal to 1 limit of the function is equal to value of the function at a. Therefore, the function is continuous. Therefore, cosec functions are continuous. Therefore, cosec functions are cosecant functions is continuous. In the same way, we can find the second function. Here f of x equal to 1 by cos 1 by cos x. 1 by cos. Where sin x is not equal to 0, here cos x is not equal to 0. Where f cos x is 0, x value is 5 by 2, 3 pi by 2 or 5 pi by 2. In the case, cos x is become 0. Therefore, 2n plus 1 into 5 by 2 is 2n plus x is not equal to 2n plus 5 by 2. Where if cos x is 5 by 2 or 3 pi by 2 or 5 pi by 2 or multiple of the 5 or multiple of the 5, the function is 0. Therefore, we take the domain here. Domain of the function is equal to r minus x belongs to r cos x is equal to 0. Where cos x is 0, that point is taken minus in the real. That is the domain. Therefore, the function a belongs to is belongs to domino F. Domino. Yeah. Then limit of the function x tends to a 1 by cos x is equal to 1 by cos a. F of a also is equal to 1 by cos a. Therefore, they are equal. Therefore, the function is continuous. Therefore, secant functions are continuous. In the same way, we can take tangent and cotangent functions also. Here also we can f of x is equal to tangent is sin x divided by cos x. Here also cos x is not equal to 0. Therefore, dominant the function is this one. Dominant the function is this one. Therefore, we can find it. Thank you. Tangent functions. Next, we will take some more problems in the next class. I will solve one problem, but battery comes low. I will solve one, then stop. Is the function continuous? F of x equal to sin x plus cos x. You can discuss the continuity. Here sin x is continuous function and cos x also continuous function. You can take it as g of x and h of x here. Therefore, the function is continuous. You can check the problem also. In the same way, or otherwise you can put the value of the f of a also here, sin a plus cos a. Yes. Then limit of the function also taken as limit of f of x is equal to x tends to a sin of x plus cos of x. Limit of x tends to a, which is equal to sin a plus cos a. Therefore, the function is continuous. Another problem: f of x is equal to sin x into cos x. Here also product of the two functions, they also continuous. You can solve this problem by using the algebra of the function also. F of g of x is equal to sin x. H of x is equal to cos x. Here g of x and cos of x are the trigonometric functions. They are continuous. By algebra of function, f of x equal to g by h. If g is continuous, g and h, g into h. The g is continuous, h also continuous, then g into h also continuous function. And we can solve one more problem here. Find the relationship find the relationship between A and B so that the function defined by f of x equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3 is continuous as f x equal to 3. Yeah, the function is continuous at x equal to 3 given here. You find the relationship a and b so that the function defined by f of x equal to ax plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3 is continuous at x equal to 3. Here we already given that the function is continuous x equal to 3. You can understand here the function is if a function is continuous, LHL limit and RHL limit are equal and f of 3 also equal. First we find the LHL limit and RHL limit. LHL is equal to limit of at x equal to 3, therefore x tends to 3 minus 3 minus is x is less than 3, ax plus 1. Ax plus 1. Therefore, 3a into 3 plus 1 is equal to 3a plus 1. Then RHL limit is equal to RHL limit of the function 3 plus which is equal to bx plus 3. Bx plus